Hi, this is Kevin from MemSQL, and welcome to today's webcast. Today we have Product Manager Stephen Camilla on the line, and he's going to be walking through a MemSQL overview and then also providing a MemSQL demo so you can see MemSQL in action. If you have any questions throughout the webcast, please answer them through the GoToWebinar question panel, and we'll field them at the end. Today's presentation will be about 15 minutes with a 5 to 10 minute demo, and we'll have some time for questions at the end. So with that, I'll hand it over to Stephen.
Thanks, Kevin, and welcome everyone to this MemSQL webcast. As Kevin mentioned in this webcast, I'll give a brief overview of MemSQL as a product, including a description of the product, some of the features in it, and some of the markets that MemSQL plays in. After that, I'll give a quick demo of MemSQL and then take some questions for Q&A. So first, a little bit about MemSQL as a company. MemSQL was founded in 2011. We're based here in San Francisco, and our goal is to enable every company to be a real-time enterprise. And what that means, I'll talk about in the next slide. Our founders were previously Facebook and SQL Server engineers, and the product we deliver is an in-memory distributed SQL database, which I'll discuss in a bit. To date, we have about 50 million in funding from companies such as Accel, the company that incubated Cloudera, Coastal Ventures, and even In-Q-Tel, the investment arm of the CIA. Our customers are all large enterprise companies. Some examples are shown in this slide, such as Comcast, Samsung, etc. The big need that we are solving here at MemSQL is to enable enterprises to operate in real time. And what we mean by operating in real time is the following. First, it should be possible for enterprises to detect and respond to business changes the moment they happen. For instance, the moment a critical transaction comes in that influences some sort of business decision, you should be able to do that in real time. Second, it is important to deliver real-time analytics to applications with growing user bases. And by growing user bases, we mean, it could be on the scale of thousands if you're looking at your data scientists in-house, or millions or billions if you're looking at web-scale applications. And delivering real-time analytics to them means being able to ingest the data and perform queries to generate analytics. And third, it's important to be able to simultaneously ingest and serve data. And data comes in through many different means, all of which are supported by MemSQL. The first one is streaming workloads. So we're looking at transaction logs coming from your ad tech application, for instance. We're also talking about transactional workloads, or traditionally called OLTP. These are like small, quick inserts, or large analytical workloads, or OLAP type workloads, which deal a lot with aggregations. So the ability to handle streaming, transactional, and analytical workloads in a way that delivers everything in real time is what we here at MemSQL provide. MemSQL powers real-time enterprises by delivering a single platform for all real-time data needs. So here in this slide, you see a sort of a more in-depth version of the diagram in the previous slide. MemSQL can handle streaming data through an integrated tool called MemSQL Streamliner, which I'll discuss in a bit. MemSQL can handle standard transactional database workloads through its in-memory row store. And MemSQL can also handle fast, scalable SQL for analytics through its disk-based column store. Digging more into MemSQL, when we're asked what is MemSQL, well, MemSQL is the following. First, it is a relational database. By relational, we mean it's a relational database management system that uses SQL. But on top of that, we also support key value pairs, unstructured data through JSON, and even geospatial data types. Through our relational model, we provide a very simple way for users to access data. Second, MemSQL is memory optimized. It's in memory. We actually have two storage formats, an in-memory row store that's excellent for quick inserts and aggregations there, and also a memory optimized column store that's on disk, which is great for storing large amounts of data. By taking advantage of memory in your system, we are able to deliver a real-time solution to the market. Third, MemSQL is distributed. Distributed means that you can install the same piece of MemSQL software on multiple machines and scale outward. MemSQL has a distributed query optimizer and execution engine built into the system. And because of its scale-out architecture, you can save costs by running MemSQL on different pieces of commodity hardware. Finally, MemSQL is designed to be deployed in the data center or in the cloud. So multiple deployment models. You can deploy it on premises, you can deploy it in Docker containers, you can deploy it even as part of Mesosphere's distributed operating system, and you can also deploy it in AWS, Azure, and in their marketplaces as well. MemSQL has two editions. A community edition that's free forever, that has unlimited capacity and unlimited scale, meaning you can store as much data as you want and deploy it on as many nodes as you want. And it has a lot of SQL features. All the SQL features you need for transactions and analytics are actually in our community edition. So if you just want to get your hands dirty and start using MemSQL, community edition is a good place to start. That said, MemSQL also has an enterprise edition where we offer a free 30-day trial. The 30-day trial comes with support, which is key. So, if you have any questions, even throughout your trial, we can answer them in the enterprise trial. It also supports a few pieces of enterprise-only functionality, such as configuring high availability, configuring cluster replication, configuring some user permissions, and some pieces of security features. MemSQL plays in a lot of markets, applications, and solutions, and this slide shows some of them. So in markets, we play in ad tech, which is serving ads to users, financial services, especially within risk management within financial services, or within matching buyers and sellers in trades. We play in the public sector, in energy, in media, in retail, and various other markets. On the application side, the big theme is real-time analytics. So a lot of these other applications fall under that bucket. So risk management and personalization fall under ad tech and financial services, portfolio tracking, monitoring and detection, all in the same spirit of being able to do all these things in real time. And for solutions, MemSQL as a very fast database that scales is perfect for Internet of Things use cases. So if you have, let's say, drill bits sending their data to a central database for processing, then MemSQL can handle that data volume. MemSQL is also good for building real-time data pipelines, meaning ingesting from a real-time message source such as Kafka, processing that a bit and storing that into MemSQL and doing that all in under a second. MemSQL can do that. MemSQL is also good for consolidating infrastructure, so you don't need multiple tiers of data storages. You don't need a cache tier and a data and a disk tier, etc. You can just consolidate them all into MemSQL. MemSQL is also good for Spark use cases, which I'll talk about in a bit, and for simplifying Lambda architectures. A little bit about MemSQL market presence. Here you can see two slides or two diagrams, one from the recent Gartner Magic Quadrant and one from the recent Forrester Wave. As you can see on the left in the Gartner MQ, MemSQL is very well placed in the Visionaries quadrant. In this quadrant, you see all sorts of vendors that don't only include in-memory database vendors, so that's why there's a lot of them. On the Forrester Wave side, on the right, these only include in-memory database vendors, and as you can see, the placement of MemSQL is excellent. We are essentially the top-ranked startup in the strong performers category, and the leaders quadrant are the folks who hold 90% of the market, essentially, of the database market. So MemSQL is very well placed inside the Forrester Wave. A little bit about the roadmap and where we've been and what we're going to do in the future. MemSQL was founded in 2011, and a year after that, we released our first database offering to the market. It was a single box in-memory database. So it was in-memory, but it was just a single machine. With MemSQL 2, we introduced the concept of distributed, which means now you can install the same binary across nodes, and we can do processing across a distributed system with massively parallel architecture. MemSQL 3 introduced the column store. So now we had a disk-based column store in addition to the in-memory row store that we've had since MemSQL 1. MemSQL 4 introduced Streamliner, which is our integrated solution with Apache Spark. We released a community edition in MemSQL 4. We have geospatial intelligence, geospatial data types, and we also have a bunch of connectors to Spark and Hadoop, which have been open sourced. We have an enhanced query optimizer that handles distributed queries in a very, very efficient way, taking advantage of heuristics, cardinality, etc. And we also have a management tool called MemSQL Ops for installation, monitoring, configuration, etc. Moving forward, MemSQL is continued, or will have continued investment in enabling real-time applications, meaning we want users to be able to access their data in real time and do analytics in real time, and we have a continued investment on that. Furthermore, we are going to do a lot more things to make data exploration and interactive queries faster, and loading into MemSQL as easy as a push of a button. A little bit about MemSQL design principles. The first big one is that MemSQL uses SQL. So this is very different from other databases that claim SQL, but really they have their own, flavor of SQL. We are, ANSI SQL, like that is our SQL flavor, and that is the only type of SQL. We are not a NoSQL database. We are not a SQL as a layer type database. Second, MemSQL really, really optimizes for memory. When MemSQL was built, we really knew that we wanted as much processing to happen in memory for massive speed. Third, MemSQL has massively parallel processing. Our distributed system enables us to take advantage of all CPUs in all machines. And fourth, MemSQL was designed to be easily deployable on-prem, in the cloud, or in Docker containers, virtual machines, or anywhere you want to deploy a database. I'll skip through the slide, but basically this says that MemSQL has made a lot of technical innovations that enable us to capture more pieces of the market and also deliver solutions that are compelling to our users from a technical point of view. Examples of which to call out here are being wire protocol compatible with MySQL, having code compilation for our SQL queries, having a distributed database joins, and the ability to support multi-mode and multi-model data. MemSQL has two storage modes, and I just really wanted to call this out in a slide. We have an in-memory row store and a disk-based column store that is optimized to run on flash or SSD. And this is extremely powerful for our users. A lot of the time we get the question, hey, my data doesn't fit in my main memory. Well, that's fine, because we also have a disk-based column store. So for transactions that you need very, very fast, small inserts, and you need the result to happen really fast, that's the row store. If you want more long-term storage and your queries are more of the analytical type nature, then that's what the column store is for. MemSQL also has a tool called MemSQL Ops, which is actually an extremely powerful tool. MemSQL Ops is a web UI or command line interface for MemSQL management. MemSQL Ops can install and configure MemSQL across all your hosts, which means even if you have a distributed system, you can install MemSQL Ops on one of your nodes, and MemSQL Ops will take care of installing the entire and provisioning the entire MemSQL cluster, which is extremely powerful, and it makes it very simple for end users. MemSQL Ops can also monitor cluster activity. It can show aggregate cluster metrics, and even includes a basic database speed test, which I'll show in a bit in the demo. MemSQL also has a tool for streaming, which we call MemSQL Streamliner. MemSQL Streamliner allows you to get immediate access to real-time analytics. MemSQL Streamliner takes advantage of Apache Spark and actually integrates Apache Spark together with the MemSQL platform. Through Streamliner, you can deploy Apache Spark with one click, which I will show in the demo. You can create real-time data pipelines in the UI and essentially eliminate batch ETL. So instead of defining an ETL job that has to run overnight, you can run a simple extract, transform, and load job that runs in under a second, essentially. And the source code for Streamliner is open sourced, and you can get it in our MemSQL GitHub space. To end, MemSQL, we would like all the data to be stored in MemSQL, and MemSQL is a very robust, ACID-compliant database. But we do understand that there's a large ecosystem of data around. So we've really built MemSQL to be able to take advantage of the ecosystem. A few things to call out here. First, in the center of the diagram is MemSQL, an in-memory database. Underneath it, in the center, you see MySQL wire protocol. Very early in our company, we made the decision to be wire protocol compatible with MySQL. This means if you have a MySQL IDE, if you have a MySQL BI tool, if you have a MySQL compatible application, you can connect that to MemSQL and get the same functionality. MemSQL supports streaming, relational types, key value, document source, and geospatial. So a wide array of different data models. MemSQL has a streamliner tool that integrates Apache Spark, an in-memory row store, and a disk-based column store for data storage. Thus, with MemSQL, we can ingest from real-time data sources, an example of which is shown here in Kafka, as you can see on the left, process that in MemSQL, and serve that to, if you look at the right side of the slide, business intelligence dashboards such as Tableau, Zoom Data, etc., and real-time applications that are built on top of SQL. And underneath, you can see that MemSQL can run on various orchestration tiers and containers on the cloud or on premises. So with that, I'll move on to a quick demo of MemSQL. So here you can see MemSQL ops. You can see here that I've already gone ahead and configured a 12-node cluster, and you can see each of the hosts here in the MemSQL ops homepage. So all the CPU stats, the memory stats, the disk stats, and the network stats of your entire cluster are visible here. What I will do now is run a basic speed test. So you can see here there's a big button that says take the speed test, and I'll click on that. What this speed test does is it runs a very simple speed benchmark, and this comes with every version of MemSQL ops. So it creates a simple table with ID and value, and the values are have a normal distribution, and at the same time it will do a select with a group by on those values and show you a graph of the distribution here on the right. So as you can see here, we are getting about 5.7 million inserts per second, and at the same time we are scanning all those rows inserted in under a second, and this is running on 12 nodes on Amazon AWS. So, and the machines are I believe M2 large, sorry. So commodity machines, and we are able to get 5.9 inserts per second on 12 machines. So for those on the call who are familiar with how fast databases can go, like this is insanely fast for a database, and we're only getting faster as time goes by. I'd also like to show you that we have Spark integration. This is the Streamliner tool. So you can click on Streamliner and create a new pipeline. And in fact, let me show you something else. Before that, this is another cluster I have running, a smaller cluster. If I click on the Streamliner or Spark tab, you see here that it tells me that Spark is not yet deployed, and with one click, I can deploy Apache Spark. And what this does is it goes and downloads a vanilla Spark distribution, installs Spark within my system, and then sets everything up, and it happens really, really fast. So actually, it's already finishing, which is great. So let me go back to a place where I already deployed Spark, and I'll create a pipeline. So I can give it any name, demo. I can specify how long I want to run my batch interval. So here I'm specifying 1 second. I can specify my data source to extract data from. I'm actually going to choose test. That way, we don't need to set up a live Kafka queue, but we can certainly do that. Then I can specify what data I want to load. I'm going to say value Apple and value orange. Right, so now I have like a set of, essentially JSON. For my transform, I can specify that I want to take this into a JSON. So just at a high level, a pipeline is an extract, which grabs data from a certain source. A transform, in this case, I'm specifying just make it into a JSON. And a load, where I specify my database, my DB, and my table. Okay, and I specify that it's a row store, and I hit run. So what this will do is it will create that pipeline. And behind the scenes, what it's actually doing is it is creating a Spark job that runs, and you don't even need to know how that Spark job is running. All you need to know is that it is leveraging Spark in the most efficient way possible and loading or extracting, transforming, and loading your data into MemSQL in a reliant way. So once it started to load, what we'll see is, so here I have a SQL terminal that relates to my databases, or my MemSQL database. If I do a show databases command here, I can see that the MyDB database has been created. So I'll use MyDB, show tables. My table is there, select star from my table. And if the pipeline's running, as you can see here, it's running. I should see a bunch of apples and oranges, and there it is, a bunch of apples and oranges. And right now I have 50 rows. If I run it again, I have 70 rows. So you can see the pipeline is running and I'm continually ingesting rows. If I click back here, I can see a view of my pipeline batches. I can even enable tracing. So what this does is, for a few batches, it actually tracks the entire state of how the data is moving along. And if I click on them, I can see that the extract took 2 records, this apple and the orange that I defined, it transformed it and it loaded it, and you can even see how much time it took for each of the phases, which is really powerful. Going back, I'm going to stop this pipeline for now, and we can see that 128 rows were loaded in total. Another demo, another really powerful thing to show in MemSQL is just the amount of records that you can load in. So here I'm going to turn on a basic row store write and do a simple count. I probably should use correct database, do a simple count. I actually like to add this format. That way we see the commas correctly. So right now we have it's going up fast. So right now we have like 5.5 million rows in the line item table. Now we have 7 million. So just in a matter of seconds, we're incrementing by 1 million rows at each time. And simultaneous to all these inserts, I can run a pretty complex query. So here's you don't need to understand what's in this query. It just, the database we have here is a PPCH-like database that has line items and suppliers. And here we ran a more complex query that returns 100 rows, and it returns in under 2 seconds. And going back to MemSQL Ops, if I look at the cluster view, you'll be able to see here that MemSQL takes advantage of all the aggregators and all the leaves and all the nodes of MemSQL to be able to run the query in the most efficient way possible. So that's it for the demo. Thank you so much for your time, and we'll go on to some Q&A.